Scientists have long known that solar-powered particles trapped around the planet sometimes disperse into Earth's upper atmosphere, where they can contribute to beautiful auroral displays. However, for decades, nobody has known exactly what is responsible for throwing these energetic electrons in their path. Recently, 2 spacecraft were found in the right places at the right time to witness firsthand both the impulsive loss of electrons and their cause. New research using data from NASA's Van Allen Probe's mission and FIREBIRD II CubeSat has shown that a common plasma wave in space is probably responsible for the impulsive loss of high-energy electrons in the Earth's atmosphere. Known as chorus in Whistler mode, these waves are created by fluctuating electric and magnetic fields. The waves have characteristic rising tones that recall the sounds of the birds that sing and are able to efficiently accelerate the electrons. Observing the detailed chain of events between chorus waves and electrons requires a conjunction between 2 or more satellites. There are certain things that cannot be learned by having only one satellite. The study combined data from FIREBIRD II, which sails at a height of 310 miles above Earth, and from one of the 2 Van Allen probes, which travel in a wide orbit above the planet. From different points of view, they could get a better understanding of the chain of cause and effect of the loss of these high-energy electrons. Far from being a void, the space around the Earth is a jungle of invisible fields and tiny particles. It is covered with lines of twisted magnetic field and electrons and chopped ions. Dictating the movements of these particles, the magnetic environment of the Earth traps electrons and ions in concentric belts that surround the planet. These belts, called Van Allen radiation belts, keep most of the high-energy particles at bay. Sometimes, however, the particles escape, falling into the atmosphere. Usually, there is a slow drizzle of electrons that escape, but sometimes the impulsive clusters of particles, called micro-granules, disperse outside the belts.